Good evening, students. Welcome back for a new chapter, a new topic which we are going to discuss, students. These are lectures are very important lectures, revision lectures for all the students. The topic which we are taking, students, is the atomic structure. But we are talking, student, atomic structure.
Atomic structure.
The objectives of our lecture is to understand what is the structure of the atom, means that what are the subatomic particles, student. Subatomic particles which are present in the atom. Understand what the atom is made up of. And you know that what we have told you, matter is made up of very, very tiny particles which are called atoms. Only 200 years back, the scientists started discovering, students, subatomic particles. Before 200 years back, there was no information that there are certain particles which are present inside the atom. Though the people knew that there are some particles which are very, very small, which make up the matter, students. And these particles, actually, you are aware of the fact that it is in 1803, the important revolution took place when Dalton proposed his postulates, or Dalton's atomic theory. Dalton's atomic theory. So everything about 200 years old, 200 years old, students, that matter is made up of very, very tiny particles, which he said atoms. And atoms, they said, are indivisible. What Dalton said, they are indivisible. They cannot be created and destroyed. But the atoms combine in definite composition to form compounds. So how did they came to these conclusions, student? As there were experiments which were being done. See, it is important. Can I see the atom? No, it's very, very small. Can I see the subatomic particles? No, they are present inside the atom, you are saying, and they are also very, very small in size and mass. Then what we and how do we get information that there are these particles are present inside the atom? The science is based on observations. Science is based on doing experiments, students. That we do experiments, and we if we don't have the machines, how do we do experiments? We are using some equipment, some machines, some tools, and if you don't have, you try to make those tools. And in order to study the particles, or in order to find information which is not visible, which we can't see. So we can't see the subatomic particles, but only in experiments we will be able to get them and get information about them. That is important. But I am saying it is only, the story is only about 200 years old, then everything started happening. Then they said, Dalton said, okay, there are subatomic, there are particles which he said smallest particle as atom. After that, you know, the experiments were done, students, for the discovery of what are the particles which are present inside the atom. So our purpose is to study. We know today that three important particles are known to us. What are those, students? Protons, neutrons,
Yes.
and electrons.
And electrons.
These are the three subatomic particles which we are saying are present inside the atom. And also we know protons and neutrons are also made up of other particles which are very, very small, quarks. But that is not our objective. So presently what we are saying that you are aware that if you will see the periodic table, if you will see the periodic table, what the periodic chart is giving you, the periodic table which you see in the book, student, there are about 118 elements How many? 118 elements are visible in the modern periodic table. Have you seen the modern periodic table, students? In the
Yes, sir.
modern periodic table, students, what do you see? List of about 118 elements. And out of this, students, you should know that only about 92 are naturally occurring elements. Naturally occurring elements.
Okay.
And there are others, then where the others have come from? So others, what are the others? After 92? After 92 actually is uranium. Uranium has two isotopes, 92 235 and 92 U238 exposure. You know, uranium is a very important nuclear fuel. In the nuclear reactors, nuclear reactions, it is used both as far as for atomic bombs as well as for producing atomic energy. You are aware of that. It is a very useful nuclear fuel, uranium 92. After that, you are saying these elements are artificial, artificially made by man. After above 92, the elements are artificially man-made. How will man make these elements, student? They are produced in the nuclear reactions. Nuclear, you have heard about nuclear reactors and nuclear reactions. So in the nuclear reaction, they are produced and very small amounts are present and very difficult to produce them. They are not we are not doing anything with them in the ordinary labs which you are using, students. So
Okay.
this is the information, and you don't have any information more than 92 naturally occurring elements. In other words, student, you know each element has an atom. What is an element? What is an element? If I say that you are saying there are elements, and in the book you say carbon, hydrogen, nitrogen, oxygen. You see these elements in the periodic table. How many? I'm saying 180. 92 you are saying are naturally occurring in nature.
Yes, sir.
You have sodium, you have potassium, you have copper, you have iron, you have gold, and so many. I mean, few of them, which I said. Few important ones are here: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. These elements are there. Each element has its own atom. The atom of one element is different from the atom of other element. Yes or no? Are the elements of atom of carbon and hydrogen same? The answer is no. That is what was proposed by Dalton, that there are different elements, means there are different atoms. Because the atoms are different, therefore their properties will be different. If all the atoms are same, then what will happen? Their properties will be same. So
Yes, sir.
if their properties are same, students, they create the world in which we are living. What is everything made up of? Now you are saying, oh, your body. I said your body have trillions of small particles, which are atoms. And these atoms are not existing as atoms, but they are combined to form molecules, compounds, and complex compounds. Carbohydrates, fats, proteins, whatever food you are eating, what is that? They are also having atoms, but different atoms have different properties, and the combination of different type of atoms, students, produces different type of matter, which you are experiencing in this world. Yes or no? So when different atoms combine, they form different substances, different compounds, and that is, I'm wearing some shirt, you student, it is also made up of certain atoms, but different atoms combine, they produce different type of materials. Whatever substances you are using at home, carbohydrate, fat, protein, whatever you are using, everything, my whole body, student, any table, any chair, any laptop, what it is. There are elements, students, and each element is different from other element because the atom of the element is different. and therefore they combine in different ways and produce different type of substances with the different properties. And you can say that basically the entire universe is made from few elements. Few elements are very common. You know which elements are very common, for which most of the stuff is made up? Carbon, you know, in your body you have carbon. Hydrogen, you know, in the universe you have large amounts of hydrogen, helium, all nitrogen, oxygen, phosphorus. Few others also, you are using iron is present, magnesium is there, potassium is there. You are eating salt, NaCl. And there are other elements which we said synthetic, man-made in the nuclear reactors now, where they are being used in the nuclear reactions. You have heard about nuclear bombs, hydrogen bombs, atomic energy, all this. So it was important, students, to understand. Scientists were very keen to find what the atom is made up of. And you know that there are certain important discoveries which are associated with the atom, student. You know, there was discovery of electron. Can you tell me the scientist who discovered electron, students? Who is the scientist who found the charge of the electron and mass of the electron? What they said, ki electron is a negatively charged particles. And J.J. Thomson, you have heard about J.J. Thomson? Heard about J.J. Thomson, student? What he did? There are experiments on discharge through gases. Gas is taken at a very, very low pressure. And when you apply high voltage, students, certain rays were emitted, which were cathode rays. And they studied the properties of those cathode rays, students. Now heard about cathode rays? Have you heard about it?
Oh, yes, sir.
So experiments were being done on discharge through gases. So in these experiments, students, they discovered cathode rays, which were negatively charged particles, and then electron was discovered. The in the atom electron, we say these electrons are. I'm not going into the complete details of that. Whatever is required for our course, we will do that. These electrons are, student, negatively charged particles. Negatively charged particles. And you are representing like E minus. This is my electron. It is a negatively charged particle, students. This, the charge of the electron and the mass of the electron was also determined. What they determined, the charge of the electron. How much was it? 1.6 into 10 minus 19 coulombs is the charge of one electron. Coulombs. This is the SI unit. Mass of the electron was determined also. These are already given in the book, students. Charge of the electron, mass of the electrons. And you further, what happened, students? Rutherford. You are aware of the Rutherford, students? What was done by Rutherford? Can you tell me? Rutherford's, you are aware of alpha scattering
Yes, sir.
experiment. As I said, the particles are very, very small. We can only see them in the experiments. We have to use
Uh,
certain apparatus.
this in this through this experiment, Rutherford made that nucleus model.
Yes, he discovered the nucleus. Discovery of the nucleus.
Then he made the Rutherford model.
Okay. Then what he was said, student, that inside the atom is present the nucleus, and nucleus, the protons are present. Protons are there. Protons are positively charged particles, students. Positively charged particles, they are present inside the nucleus. They are present inside the nucleus. And the size of the nucleus is very, very small. The inside the nucleus, they said he was able to make calculations after doing his alpha scattering experiment by using a thin gold foil. What he used was a thin gold foil. These are experiments we already know. We are not going into details of that. So this experiment was done, alpha scattering experiment. Alpha rays are doubly charged helium atoms. When they were bombarded on thin gold foil, most of them passed straight, few were deflected, 1 out of 12,000 rebounded back. And after doing the experiments, he proposed a very simple picture of the atom, in which he gave his what we call as a Rutherford atomic model, and in which what we say that in nucleus is the center of the atom, and the size of the nucleus is very very small. For example, if the diameter of atom student is around 10 minus 10 meter, then the diameter of the nucleus after calculation comes to around 10 minus 14 to 10 minus 15 meters. So you see how small it is, about 10,000 to 1 lakh times smaller than the atom. This is the size of the nucleus. So can we see these things? No, only in experiments, student, experiments. What in science? You are observations, experiments, and then you are giving some results, some theories, some model students. And you know, the discovery of protons, canal rays, positively charged rays, and they found also the mass of the proton. Mass of the proton student was obtained to be equal to 1.67 into 10 minus 27 kg. You see how small is the number. This is the mass of the proton, and also the charge of the proton. Charge of the proton was also experimentally determined, students. We write 1.6 into 10 minus 19 coulombs. This is the same as the charge of the electron, but sign is opposite because protons are positively charged particles. Protons are positively charged particles. And then students, neutrons were also discovered. These are the particles which have no charge, no charge. But protons you are representing like P, and neutrons you are representing like N. Neutrons, they have no charge, but mass almost equal to protons. ठीक है? And these smaller particles or subatomic particles are discovered by experiments. Their charges are determined by experiments. Their masses are determined by experiment. Neutrons are discovered in nuclear reactions. And what is the picture which we have today, student? After in earlier 20th century, we are talking earlier 20th century. So what was proposed, what we say, what we are saying, that if I say something like nuclear model of atom, what we are representing, student, that there is a nucleus inside the atom which contains neutrons and protons. What the nucleus contains? Neutrons and protons. Simplest picture. I am saying what is the simplest picture of atom? I mean simplest picture of the atom which we can give. It is correct or not? I am not talking of that yet, but for our purpose, the reason we are learning atomic structure, because students, we will learn the writing of electronic configuration. which will be very useful for chemistry purpose, because these are the electrons which will take part in the reactions, not the protons or neutrons. They are present inside the nucleus. They are called nucleons, and the binding energy and the forces which are binding these particles are very, very large. They are only participating in nuclear reactions. So mostly what we study the chemical reactions in which electrons will be involved. So what we are saying, the simplest picture, that inside the atom you have a nucleus, and size of the nucleus you have said about 10 minus 15 meter. Size of the atom you are saying 10, right, radius of the diameter of the atom you are saying 10 minus 10 meters. Very small nucleus. Nucleus contains neutrons and protons, and electrons you are saying are are in the orbits around the nucleus. A simple picture we are seeing. So you have electrons, and you are saying they are in the orbits around the nucleus. This is the simplest picture which we are giving. There are different orbits, there are different shells outside the nucleus in which the electrons are orbiting, are moving, student, with very high speed, with very high speed. And in the books you will find, in the books you will find what information you have. Now we are saying the information about atom subatomic particles. There are subatomic particles which are present inside the atom nucleus. Electrons are orbiting around the nucleus, and most of the space is empty, means alpha particles pass straight through the atom, student. And the volume of the atom will be mainly decided by the electrons, because they are outside the nucleus. Nucleus is very, very small, 10
Yes, sir.
minus 15 meter. Size of the atom is 10 minus 10. So 10,000 to 1 lakh times the size of nucleus. Therefore, these are the electrons which will determine the size of the atom. They are orbiting outside the nucleus. So students, you are saying you have got protons, neutrons, and electrons inside the atom. These are the subatomic particles discovered by experiments. I have not seen them, you have not seen them, but experiments have been done, and they are giving their masses also. And if I say something like this, what is their particle relative mass, students, and relative charges. These are relative, means with respect to one another. Actual mass of the proton, I have told you how much, 1.67, 10 minus 27 kg, which is very small number. This is determined experimentally. Mass of the neutron is also almost equal to proton, and mass of the electron is about 1 by 2000 times that of the proton or neutron. The mass of the electron is negligible as compared to the mass of proton and neutron. So particle, if I say proton, neutron, electron, proton, neutron, and electron. These are the particles. These are the particles, student. Which one I am saying? Proton, neutron, and electrons. Okay? Relative masses. This is 1 unit. This is 1 unit. And electron is 5 into 10 minus 4. About 1 by 2000 times these protons and neutrons. And relative charges, I am saying this is +1. Neutron is 0, and this is -1. These are the relative. So proton charge and electron charge, they are equal and opposite. And these cannot be observed directly. They are discovered, student, and experimental data. This experimentally I am saying. So every data is experimental data. We just can't say. 200 years ago, no, there was no mention of these particles. But after that, early 19th century, you started knowing proton, neutron, electron, and the discovery of this particle, student, has transformed the entire science. The modern science which you are learning, which you are working, this is all based on these subatomic particles. What is important? We talk of atomic number in atomic structure chapter. What is atomic number, student? What is atomic number? You are, I said, periodic table, go and see. You see 118 elements. Their names are given. Names are given. What? You are saying carbon. You are representing by C, hydrogen. You are representing by H. You are saying sodium. What symbol you are using in the periodic table? And you are saying gold. What symbol you are using? Gold. Au. All this you can see so many silver, Ag. Did you see that in the periodic table?
Yes, sir.
And each element has the same atomic number or different atomic number? Tell me.
Dif- uh, Different atomic number.
Each element is having, each element has a different atomic number. Different atomic number. Very important point. That means instead of this symbol or name of the elements, if I write in the periodic table atomic number 1, 2, 3, 4, 5, 6, 7, 8, like this, if I write the atomic numbers, then one atomic number will represent an element which is different from 4, yes or no? And
Yes, sir.
if I say atomic number of, supposing I say atomic number of sodium is 23. So if I don't write sodium, if I say atomic number 23, then you will know which element it is, yes or no?
Yes, sir.
Therefore, student, atomic number is very important. When I say, if I say gold has atomic number 79, student, no other element will have atomic number 79. Will any other element have atomic number 79? No, because it is not
No.
gold.
Yes,
Yeah,
sir.
this is very important information. Then what is this atomic number? This is represented by symbol Z, and it is unique for every element. Unique for every element. Yes or no?
Yes, sir.
And I can, instead of giving the name of the element or symbol, represent the atomic number. If I write 12 atomic number, then it is carbon. Or if I write 12, then what is the element with atomic number 12? Carbon is 6 atomic number. If I write atomic number 12, which element will be that? You can see here, lithium, sodium, potassium, oxygen is 8. So we can see the periodic table of the element. Atomic number 12, I think it is magnesium. Magnesium. So by atomic number, we can identify the elements. And atomic number is nothing but equal to number of protons. Atomic number Z is equal to, student, number of protons present in the atom. Number of protons in an atom. And where are the protons present inside the atom? Inside the nucleus. Inside the nucleus. Yes or no?
Yes, sir.
So if I say the atom has got 12 protons, what is the atomic number? 12. If an atom has 15 protons, what is the atomic number? 15. So
Yes, sir.
atomic number is equal to number of protons present inside the atom. But you know atom is neutral. Atom is neutral. Yes or no?
Yes, sir.
Therefore, inside the atom, number of protons must be equal to number of electrons. Therefore, student, I can say atom is neutral. For a neutral atom, I am saying atomic number represents the number of protons. Atomic number Z is equal to number of protons. And a number of protons is equal to number of electrons. Right or wrong?
Yes, sir.
Okay. So we can say that atomic number can be defined in terms of protons mainly, but why do we don't say atomic number will always be equal to number of electrons? Why? Because students, you are saying what you are saying, the model of the atom, you are saying this is a nucleus. Okay, this is a nucleus, and you have got shells in which students there are electrons. There are electrons in these shells. Okay, these are the shells in which electrons are present. There are more. Okay, this is called K shell, L shell, M, N. There are, supposing here there are two electrons. These are orbiting around. This is a nucleus. This nucleus contains neutrons and protons. These are in the shell. You have got electrons. Electrons. Okay? E. Here also you have electrons. Now, when what happens, students? Why do we say atomic number of an atom equal to number of protons? Why do we say that? Because students, electrons can be lost or gained. Electrons can be lost or gained during the chemical reactions. What happens? These are not the neutrons or protons which are taking part in the chemical reaction, because they are inside the nucleus, and they will only be changing or reacting in nuclear reactors, nuclear reactions, which will require very high energy requirements. The nucleons are bound by very, very strong binding energy. There's a very strong force which is holding them. Then what is happening? Electrons can be lost or gained, students, when whatever reactions or whatever chemical reactions you are doing in chemistry or in science. So therefore, we represent what we say atomic number is defined in terms of protons, because in chemical reactions electrons can be gained or lost. Yes or no? Okay? And then another definition is defined as mass number, student. If I say mass of the atom, what will be the mass of the atom, supposing? When I talk of mass of the atom, student, again there is a relative scale which has been given. As you know, the mass of proton is very, very small. Mass of neutron is also very, very small. Mass of electron is 1 by 2000 times. So usually when I say mass of an atom will be equal to mass of proton, how many protons are there, plus mass of neutrons. Both are these present in the nucleus,
Yes, sir.
and mass of electron is negligible as compared to these two.
Yes, sir.
This is negligible.
Yes, sir. It is negligible.
Negligible, student. It is 1 by 2000 times that of proton or neutron. So I can neglect this when I add it.
Yes,
I
sir.
may say mass of an atom is equal to mass of proton and mass of neutron. I may ignore this because it is very, very small. So entire mass is present where? Inside the nucleus. Or I may represent something called a mass number, which is called as sum of the mass number is defined as number of protons plus number of neutrons, number of protons plus number of neutrons. Okay?
Yes, sir.
Which is present inside the nucleus. They are present inside the nucleus. Because the mass of electron is very, very small. So we say that, oh, mass number is almost representing the mass of the atom, because the entire mass of the atom resides inside the nucleus. So we define a mass number, student. Then if I say P is protons, N is neutrons, uh, Z is my atomic number, Z is my atomic number, then I can define a mass number M. Mass
Yes,
number
sir.
M. This is my atomic number. Then what is Z? Z is equal to number of protons, you are saying. Z is equal to number of protons, and mass number is equal to number of protons plus number of neutrons. ठीक है? Or if I represent this by A, in certain books they are representing this by A, mass number is represented by A, then I will change it. Okay, if any doubt could be there in the students. Okay, let me represent it by A, student. If it is A, okay, no problem. Whatever symbols are used in the book, we can use it. So we are saying mass number of an element can be represented by A, then A is equal to P plus N, P plus N. So the mass number is equal to protons and neutrons, student. So for any element, if X is the element, student, for X is the element, then it has got two things. One, atomic number,
Yes, sir.
which we call as Z, and mass number, which I call as A. And there it is represented, how we represent. Uh, X can be written like this, as the convention which books are using, student. Here I am saying this is my mass number and this is my atomic number. So you will find in the books they write like this. For example, if I write 11 Na23, what it means, students? What is 11? What is 11? Atomic number.
Yes, sir.
And what is 23? Mass number.
Yes, sir.
So we can say that, what we can say? I can write it like this, student. Supposing I said 11 Na23. So you are saying A is equal to 23 and Z is equal to 11. Therefore, this is equal to P plus N, and this is equal to number of protons. How many protons are there? 11. Then how many neutrons? How many neutrons will be there? Tell me, 30 seconds for answer. What is the value of N in this case?
Um, 23 and 23 minus 11. That means
12 neutrons.
12.
Therefore, I can say that there are 12 neutrons, 11 protons. And how many electrons if I say? Because electron is a neutral atom. Neutral atom. In a neutral atom, what I said, number of protons is equal to number of,
Number of protons is equal to number of electrons.
because the charge is zero now. Equal and opposite charges. Equal and opposite charges. Therefore, I will say that in this case, what I have written, how many protons are there, students? 11. How many electrons will be there? 11. 11 protons and 11 electrons. Therefore, students, we have started identifying the elements by their atomic numbers, and they have a mass number which we are saying is P plus N,
Okay.
almost equal to the mass of the atom, assuming the mass of the electron is negligible. So we can say that in the case of sodium, sodium has a nucleus.
Yes, sir.
Nucleus contains the nucleus of the sodium will contain how many protons? How many neutrons? 12. And outside the nucleus, students, you have electrons 11. They are outside the nucleus.
Yes, sir.
Okay. So the symbol is we have represented like this. You can take any elements. Supposing I say 8O16. Tell me how many protons, how many neutrons, and how many electrons present in this oxygen? You have 1 minute to answer the question, student. 1 minute to answer the question. How many protons, neutrons, and electrons are present, students? Give me the answer. Give me the answer.
Okay.
What is the atomic number? 8.
Yes,
There will
E
be
is
8 protons.
8. Neutrons will be
And mass number A is how much? 16, which is equal
16.
to protons plus neutrons. So 16 is equal to 8 plus
8 plus
16
neutron is equal
minus
to
8,
16 minus
8,
8.
8 neutrons. How many electrons?
8.
8. So this is oxygen atom. Oxygen 8O16. ठीक है? Can I proceed further? Any doubt?
Yes, sir.
Okay. Next, what we find, student? Ions. What are ions, student? They are charged particles. How will they will formed? If an atom, student, loses electrons, or
Okay.
atom gains electron, then what will happen? It will become charged. It will become charged, student. If it will lose electron, then what will be the charge on the ion? It will become positive ion. Positive ion. And if it gains electron, then it will become a negative ion. Yes or no? Tell me. For example, if I have sodium, ठीक है? If sodium loses electron, what will happen? It will become Na plus and one electron lost. This is called a cation. Positive ion is called cation, students. If I consider magnesium, supposing it loses one electron, further it loses another electron and it forms Mg2 plus. How many electrons then? Plus 2e.
Plus 2.
Loss of electron, then what is this magnesium ion? What is this? Mg2 plus. This is cation. If aluminium 3 plus, that means it is a positive ion.
Yes, sir.
These are examples of cations, student, positive ions. And the atom, this was the atom, sodium atom, magnesium atom. They lost electrons. Certain atoms you can see gain electron. Why they will do that, we will also present in our coming lectures.
Can
If
you
I
please
have
go on?
oxygen gains 2 electrons, then what will happen? It will become two charges. Two charges, I represent it O2 minus. This is a what? Negative ion. This is called
Yes, sir.
anion. Negative ion is called, student, anion. So there are two types of ion, student. Gain of electron. If I have Cl and it gains one electron, then it becomes Cl minus. This is a negative ion. Negative ions are called anion, student. So we will experience ions negative as well as positive. So you are now becoming familiar with certain things which I talked about: A, Z, neutrons, protons, and electrons. These terms are becoming clear to you, students.
Yes, sir.
We are likely to use them. We are likely to use them. Okay, you have noted down. I will proceed further. Can I proceed further, students?
Wait, sir.
Note down everything. We are building a very, very important topic, student. Atomic structure is very important. After that, we will be able to know a lot of information.
Yes, sir, I've done.
Okay. Further, students, isotopes were discovered. Isotopes were discovered in nature.
Sir, before we continue, can I go to the washroom?
Okay, go ahead. Students, what is important? Isotope concept is very important because in nature, it was found that the same element have different atoms of the same element. What was found? Different atoms of same element, student. Different atoms of the same element. Different mass number. Okay, what I am talking, student, very important thing. It was found in nature. For example, when they were studying hydrogen, what is the atomic number of hydrogen, student? One.
Yes, sir.
I mean, it has Z equal to one means one proton. One proton or also one electron. But when they were studying, student, in the nature they found there were three atoms of hydrogen. How many? Three were obtained. So this is one atomic number and proton mass number one, atomic number one, because there is only one proton, zero neutron zero in this. It was found in nature, students. They found there are three atoms of hydrogen which are existing in nature. This is present in very large amount, and the other two were discovered, which were discovered 1H2 and 1H3. So these two atoms there are three atoms of hydrogen which are found naturally occurring. Naturally occurring what? How many? Three atoms of hydrogen. So what is different here? They have different mass number but same atomic number. As you can see, their atomic number is same, but
Uh,
mass number is different.
yes.
And these are called isotopes. These are called isotopes. Hydrogen has got three isotopes. which are naturally occurring. So what will be the difference here? Here you are saying mass number A is 2 and Z is equal to number of protons 1. Then there will be how many neutrons? What is A, P plus N? How many neutrons will be there? Tell me. 2 minus 1, 1 neutron. So it has got 1 proton and 1 neutron. And how many electrons are there? You already know. Electrons 1, because there is no charge on the atom. And if I consider 1H3 students, then what is the atomic number? What is mass number? Mass number is 3. And what is Z? Z is my atomic number. How much? 1. So proton 1 and electron 1. Then what is the story? P plus N is equal to 3. How many neutrons? 2 neutrons.
Neutron.
So the isotopes have same number of protons because atomic number is same, but different number of neutrons. Is it clear?
Yes, sir.
Therefore, you are saying these isotopes have same number of protons, but different number of neutrons. And their abundance is different. If supposing this is 99.99%, this is 0.001, this is 10 is to minus 13 of that. Very, very small amounts are present. Even the names have been given different. This is called protium, this is called deuterium, and this is called tritium. 1H1 student, 1H1 is called protium. And this is our hydrogen 1. And the second one is called 1H2. This is my hydrogen 1. Hydrogen 2, this mass number 2. This is represented sometimes, this is represented by D student. This is called deuterium. It is heavier, 2 times heavier than this. Deuterium is 2 times heavier than protium. And third one is called hydrogen 3 and is called tritium. Tritium students, and can be represented by T. So there are 3 isotopes of the hydrogen. How many? 3. They have the same atomic number, but mass number is different. Mass number is different, students. And we can calculate how many protons and neutrons are present in them. Similarly, it has been found in nature: carbon C6H12, C613, C614. This is a radioactive isotope of carbon, which is used for carbon dating, finding the old age of the old objects. Archaeological, used in the archaeology. The half-life is known to us. We will explain in the later chapters. Similarly, you will see chlorine 17Cl35 and 17Cl37. There are 2 isotopes. And because there are isotopes, their percentage abundance is different. Their abundance is different, student. Their abundance is different. One is present in very large amount, other is present in very, 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 very small amount. And then if we will find the masses, students, what will happen? You will see that the mass, in the mass, if I see the mass number of Cl in the periodic table, student, in the periodic table, you will see value 35.5 mass of the chlorine. How they give mass? If you see the mass 35.5, if you see the mass. So why it is coming in fractions, student, because protons and neutrons cannot be in fractions. Protons and neutrons cannot be in fraction, but you are getting a number 35.5, and others also you are getting fractions. Sometimes for the hydrogen they are writing 1.008 u. What it means? These are the average atomic masses, students. Average atomic masses. Because there are isotopes. And if I know their abundances, then I will find that the average atomic masses will not be whole number, students. These are not whole numbers. Protons and neutrons are whole number, but these masses are not whole numbers. Because of the existence of isotopes, we talk of average atomic masses, which are not complete whole numbers, students, which are not complete whole numbers. And these isotopes, students, they have the same chemical properties because atomic number is same.
Yes, sir.
Same number of electrons are there. Electrons take part in chemical reactions. ठीक है? They will react in the same way, but they have different physical properties because their masses are different. If the mass is double, for mass 1H1 and 1H2, mass of the 1H2 deuterium is double. You have heard about heavy water, D2O. D2O heavy water, student, the property will be different. Physical properties are different. That means their melting points and boiling points will also be different. Are different, students. So because one is heavier, other is lighter, their speed will also be different. They will be atoms move at different speeds, students. So their boiling points will be different. For example, uh, for example, 1H2 boiling point minus 253 degrees Celsius, and boiling point 2, 1H2, the boiling point is minus 250 degrees Celsius. See, the difference is coming. And D2O is called heavy water.
Okay.
What you are drinking is H2O. This is present in very, very small amount, very small amount, even in this water. Because in the nature you have deuterium also and hydrogen also. And melting point, this is 3.8 degree Celsius D2O, and boiling point is 101.4 degree Celsius. Water boiling point, you are saying 100 degree Celsius, and what is the melting point of water? 0 degree Celsius. See, the difference is there because the masses are different. Their physical properties are different, students. These are what we call as isotopes. Therefore, students, I end up my lecture here today on the atomic structure.
Okay.
We have learned atomic number, mass number, isotopes, the subatomic particles, their relative atomic masses. We have learned about the ions. We will continue more about this in the next lecture. Therefore, you keep on practicing more and more questions. Bye bye. Good night. I will see you in the next class. Okay. Good night,
Thank you, sir.
students.
Good night.